Hi, we're back. We have the IMA806 sitting on the bench where it was last night when I finished the first video. Today is Intercom Triage to figure out which board or boards has a problem. To review, this is the problem. When you power it up, it does that. I believe it's going to be either a problem with the intercom board or a problem with the control and audio board. These are boards that belong to me. These are both good boards that have been tested and repaired actually, because you can see this one has ICs in sockets. Because when I repaired this at some point, I don't remember, it's been probably 25 years. I put sockets, somebody put sockets, I put sockets, or NuTone put sockets. I think I did. I don't remember. It's been a long time. This one also has one IC in a socket. Sometimes those are good clues because oftentimes the same part fails on the same board all the time. And if these parts were replaced, there's 5 on this one, 1 on the other one, those may be the most problematic parts on the board. I don't really remember. It's been a long time, but I know these are good because they're from my set of boards that I know works. So the first thing we're going to do is we need to take this apart. This is a fairly straightforward thing to do because on the back of the 806 there are 2 flat gray ribbon cables, the wide one and the narrow one. They're different sizes and they simply unplug from the terminal board and that disconnects it, which makes my life easy. This was designed to be easy to service and install in some ways. And then these cables actually can unplug from the board also, like that. And this one off the power supply board. So we can put those off to the side. That just makes it a little bit easier. We're going to start with the easiest one. So this is constructed of, there is a total of 1, 2, 3, 4, 5, 6 circuit boards. Power supply board here, control audio board here, the display board is underneath at the top, the intercom board is underneath at the bottom, and this is the tuner, and this is the little switchboard here, which we'll talk about after we get the set working, because this has some inherent problems also. So we're going to start with this board because it's the one on the back, so that makes it easy. All the board interconnects, all the other flat gray ribbon wires simply unplug like that. And that makes life a little bit easier. There's 2 blue wires that come off the control and audio board and connect to the speaker. Like that. There's a green ground wire. And there's this other ribbon cable here on the edge, is P101, and this one right here, which is X101. Never understood why they labeled it as X something, because usually in electronics, X is for a crystal, and it's not a crystal, so I don't know. The other thing I know about this set at this point is this set's been worked on or at least taken apart at some time in the past, and I know that because about half of the screws that hold the boards in place are missing. So someone took it apart at some point, and when they put it back together they didn't bother to put all the screws back in. So this board, once you take, it has 4 screws but it only had 2 in it. This board just lifts out. Here's our intercom board and this is our display board. The other thing I find interesting on this is there's a date code on this. On the chassis it says E82D, which means it was made in 1982, ABCD, for April of 82 it would be. It's got some other writing on it in sort of felt pen or something. So 1982 here, the speaker cone here says 83. And if we look at our integrated circuits, if there's date codes on any of these, some of them are early or mid 82, some are, they're upside down, 83, 10th week of 83, 11th week of 83. So the board looks like it's early, but the faceplate label says IMA. So it's kind of disjointed there in my way of looking at it. Not sure, don't know. Probably doesn't really matter. So we'll take this board, and one of the things we're going to do is we're going to mark it with some felt pen here. Find a good place to write it. Because when you have many boards, you don't want to mix them up. So I just labeled it as original. So I know that was the original board in the set. So we're going to take our control and audio board and put it in place. And we'll follow the best practices of the last person that worked on it. We'll just put a couple screws in for now. That one. And this one. And we'll plug our ribbon cables back in. Don't forget your ground wire. That's important. In typical NuTone design, it would have been nice if the wires were all just a little bit longer. You know, an extra inch makes all the difference in the world. Alright, plug this one in, and this one goes down here. This one's always tricky to do because it has sort of a right angle connector. Alright, and then we have to put our big ribbon cables back on. So one of the things about these are, I think these were probably not specifically made for an 806. These are probably an off-the-shelf ribbon cable that some company made. And for instance, the plug here on the power supply board has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pins. And this plug has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 openings in the plug. So when you plug this in, you offset it by 1. So you've got no connection on the pin here and no connection on the pin there, and the same thing is true on the terminal board. This one is the proper width and it just plugs in. Also, these are indexed. There is, it's probably a little hard to see, this side is flat, this side has a little notch in it, and the notch goes up against the white part of the plug, like that, as if it were to lock in place against the white part, even though there's no tab on the white part to actually hold it in place. One of the things about an 806 is you must not ever connect or disconnect the master from the terminal board while it's powered up. We talked about in the first video the problem with the type of integrated circuits and things they use, and you don't want to shock the system by plugging it into power, because here's our low voltage transformer. It's wired, it's a multi-tap transformer. There are 2, 4, 5, 6, 7 leads that come out of it for different voltages, and ultimately that ends up in this connector here. And you don't want to plug it in here while the transformer is powered up. You want to turn it off, turn off the circuit breaker, then unplug it, work on it, then plug it back in, then turn the circuit breaker back on. So there's our board replacement. Let's get an antenna. I'm going to be overly confident here. Hook this up. Now we're going to turn it on. So, one thing to know, no noise. That's good. However, in a properly working 806 system, when you power it up, it goes into intercom mode automatically. Why? I don't know. That's the way it is. So you have to push the end call button. Still no noise. The other thing about 806s is there is no clock. This display is strictly for the AM FM radio station to read out. So we'll do power on. We have sound. Program select. FM. Tuning.
In a very world.
We have music.
We're hungry. Love will keep us alive.
Maybe today will be our lucky day. So let's get our remote speaker, which is wired up to the terminal board. Right here. Oops. And turn the music back on. Works. All right. Now we have to try the intercom. One thing about this, and we'll do more detail on this in the future, or as the videos go along. These 4 buttons are your intercom buttons. You have end call, phone talk, door talk, and inside patio talk. These operate like almost all intercoms that NuTone made, really starting in the ones that were most successful were in 1984, but it was a new layout except for the phone talk thing. So you have inside patio talk, door talk, end call. Those are the ones we care about. The problem with this design is, while these look like 4 buttons, these are all molded on one piece of plastic that's attached to the back of the faceplate. And the way it was manufactured was the piece of plastic has 4 holes in it, and they fit over 4 plastic pins on the back of the faceplate. There's a little strip of metal, and then those plastic pins, they're heat stakes. So when it was all assembled and the metal piece went on at the end, then they were melted and squished down to hold them in place. The plastic breaks off, and now when you push one, they all move. And the way it's supposed to work is, because they're all fastened individually, you can push them all individually one at a time and the other ones stay still. So it creates a problem when they break loose, because when you push one, it's like you're pushing all of them, and you're not supposed to do that. So I'm going to have to hold these out a little bit and then try to push it and tap on it. Sorry about all the feedback. Welcome to the world of fixing intercoms. This is because the speakers are too close to each other and it's cycling through, it's feeding back from one to the other, and it's really annoying. The intercom actually works. One of the unique things about 806s is, instead of using the speaker cone as a microphone when you're speaking through the intercom, there's a little condenser mic right here, which is actually on the intercom board right here. It's a little condenser mic. It's the first time they ever use a condenser mic in an intercom system. It greatly improves the clarity when you speak into it. And on the remote speaker right here, in this part, right behind the grill, is another condenser mic on the circuit board for that. And so the intercom basically works. We'll have to spread these apart at final testing, but I'm pretty sure we're okay. So this is our control function switch here. We have monitor, normal, and private. So if we put it on monitor, it puts this into permanent talk mode. That works. If you put it on private, it prevents people from listening in. This was the very first system that had automatic hands-free reply, which means that it's push to talk and release to hear the reply. The person that's replying at the remote station does not have to go right to the station and does not have to push the intercom buttons. They just speak and you'll hear them. So it's hands-free reply. If you put it on private, it prevents someone from listening in to you in your location if you have an intercom station near you. The idea being that if it's push to talk and release to hear the reply, in theory, you could activate the intercom, push and release, so it's in reply mode, and if there is someone in another room speaking, you could overhear what they were saying. You can eavesdrop on mom and dad. If you put that station on private, it turns off the hands-free reply from that station. Then you have intercom volume, you have volume, which is the music volume, you have tone, and what we used to say about the tone was you can have treble or less treble. Not really a lot of bass in these. And then program select switches between FM, phono, tape, back to FM, and a separate switch to turn outdoor patio stations on or off. That's for the music. The intercom always works. That was to combat installations in housing developments primarily, where every house would have an intercom system and people would have their systems on during the day and it's playing through the backyards and everybody can hear everybody else's, and that wasn't very popular. Where we are right now is, it seems as if our original control audio board has a problem. Now the job is to figure out what the problem is. So this is our control and audio board. This is the original one out of the set. And we need to go through, and the first thing I like to do with a board like this is not a board that I work on very often. It's been 8 years, maybe longer. I can't remember. I remember the very first one of these I ever repaired. That was all the way back in the mid-1980s. The first thing I like to do is a quick visual inspection, because you might find something that's a clue. It's not a huge board, but it's a double-sided board. There's circuit traces on both sides. All the components are primarily on the top of the board. However, there are a few on the bottom. Sorry about the reflection. These are all bodged in. These are part of the modifications that were done to the board at some point. There's a resistor here and 2 diodes. It still counts as a single-sided, it's a double-sided board with a single side load. First thing to do is a visual inspection. The only thing that jumps out at me is this integrated circuit right here is in a socket, and that looks like it was done that way from the factory, although somebody did the bodges on the back, so hard to say exactly. Other than that, I don't find anything else here that looks out of the ordinary. There are no holes blasted through the bodies of integrated circuits. There are no resistors that are burned up. Nothing that seems obviously wrong. The other thing that's interesting about this board is you've got integrated circuits. You have different types of capacitors. You have a lot of resistors. There are diodes. This is a little reed switch. There's not a single transistor on the entire board. It's all about the integrated circuits and their supporting components. So the first thing we're going to do is I'm going to go through and I'm going to check all the diodes first, because it's possible that you might have a shorted or open diode, and that is creating the problem. So I'm going to use my little Atlas Peak DC-A75, which is quick and easy. All you do is you clip on to the leads of the diode, push the button, wait a second or two, and it'll tell you what you got. Diode junction, forward voltage 0.659, 5 milliamps, perfect. I'm going to go through and check all these. This part will probably be time-lapse. I'm not going to edit it out so you can actually see me sit here and do it, but it'll go super fast, and I'm not going to talk. Okay, all the diodes test good. That's good. One thing off the list. The next thing we're going to do is, although I don't think it's going to solve the problem, I'm going to go through and replace the electrolytic capacitors. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not very many. So I'm going to do that. I doubt that that's the problem. It needed to be done anyway, so we're going to do that now. On the off chance, this one looks a little dodgy to me. All the other ones appear to be okay, but if you factor in the age of the unit and that it's been on 24/7 for the last 40 plus years, it's a good idea to change them, and we have to do it anyway. So that's the next step. Okay, so all the electrolytics have been replaced. So now it's time to put the 806 back together. I don't think that we will have found the solution at the moment, but we shall see. And for those of you who might be wondering, there's a reason why I decided to do it in this order. First, checking the dozen or 16 diodes on the board is simple and easy. And sometimes you get lucky. The other thing, the reason why I decided to replace the electrolytics is because the next step is going to be to start checking and measuring the voltages. And if you factor in that the electrolytics are going to need to be replaced anyway, and if you're going to measure voltages, the electrolytics are part of those circuits, so it makes the most sense to take care of them now, because as you saw in what will be probably a fairly rapid time lapse, it didn't really take very long. All right, all that, plug this back in here. turn this back up. We won't bother putting an antenna on it yet because we're going to know as soon as we hit the power whether it's better or not. I'm betting not. Nope. Same. Alright, so now there's going to be voltage measurements. And again, because that's not hugely exciting, it'll probably be a time-lapse thing, so I have to set up for it and then I'll be back. Okay, so I've got it set up to measure voltages. It's powered up now. I disconnected the remote speaker and I disconnected one lead off the master station speaker because I don't want to sit here and listen to the chirping sound while I do this because it's too annoying. So what we're going to do is we're going to measure voltages across the main board, the control audio board, and we're going to use the service manual and use the voltage chart for the parts for the integrated circuits on that board. The first thing we're going to do is this small cable here, which goes down to the power supply, is the primary power for the board, comes off the power supply board. So I have one probe lead plugged into the green ground pin here because that's what it says to do in the manual. And if we measure, this one should be +5, pretty close. And one of the things you have to consider is there's the voltages in the manual and then there's the voltages in the real world, and they're not always exactly the same. Like this board says it's supposed to be 5 volts and we're getting almost 6. And this one's supposed to be -5, and it is. And this one's supposed to be 12 and it's 12.7. That's all close enough because the power supply board is older and it needs to be rebuilt, but they're close enough for now. What we're looking for is grossly wrong voltages. So what I've decided to do is, this is the amplifier IC. So one of the things you try to think about is what components are on the board that could fail in a way that's creating what's basically an oscillation, which is what we're hearing. So we'll start with the amplifier IC here. This happens to be Z115. It's only got 6 pins, so it's pretty easy. Pin number 1. And the nice thing on this board, the silk screen, all the labeling on the board, it shows you on each component which pin is 1 and so on and so on. Not every pin is numbered, but it shows you which one is 1, so you know where your starting point is, and you go down and it's pretty straightforward. This should be a 0.5 volt, and it is. I'm rounding it off. It's 0.45, but you know, it's close enough. This one is a 0.5 volt, and it is. One of the things you have to be careful of when you're probing a live circuit is you don't want your probe to slip. Like this integrated circuit here, there's 5 leads, not 6. You're measuring on the top of each one. If your probe slips and shorts between 2 and 3, then you're going to have a problem maybe. So don't want to do that. You got to be really careful. Number 3, 0, which is fine. Number 4, supposed to be 5.6 and 6.08. That's fine. And this one, 12.7, supposed to be 11.9. That's fine, because also over here where it comes in off the board, off the power supply, it's also 12.7, so we're getting our 12 volts. It's real world numbers. Now, the other thing I want to do is, we talked about this little integrated circuit right here. This one is the one that's in a socket. So it's been replaced before because NuTone didn't put any integrated circuits into sockets except on the i600 system where they're all socketed. And that's a thing for the i600. This one I think has been replaced at some point, and that could be when it was worked on before and the person didn't put all the screws back in. It's a clue, and we're always looking for clues. So we're going to do this one. This is Z110. So look on the chart. Pin number 1 is supposed to be 0 volt, and it is. Pin number 2 also should be 0 volts, and it is. Pin number 3 is supposed to be minus 4.16 volts, and it's minus 3.98, close enough. Number 4 is supposed to be minus 4.2, and it's 4.12, that's fine. Pin number 5 is supposed to be 6.3, and it's 5.3. It's a volt low. That's interesting. And then we should also have 6.3 on the next one. pretty close. And then minus 5.3, and that's pretty close. And then we'll jump up to 8. 8's supposed to be, oops, sorry, 8. 8 is 0, which it is. 9, 0, 10, 8.5 millivolts, not quite 0, minus 5.3. And then minus 4.6, that's pretty good. And then 5.3, minus, yes, and 6.3. So those are all pretty close. I'm going to check this one again real quick. That's okay. And that one's okay. And that one's low. Don't like low. So now I'm going to sit here quietly and go through and measure each individual integrated circuit and compare it to the voltage chart, and anything that seems out of the ordinary gets marked with the red pen so we can go back to it and see. So not exciting, and it'll be a time lapse thing again because that's the best way to do this. Okay, I haven't done the whole board, but I've done some of it. And what I found so far is that, unplug this. This one's got one pin that's off. This one's got one pin that measures wrong. This one has several pins that measure wrong. This one, all the first 8 pins, 7 of them are way, way off, which is suspect. So what I'm going to do is, I know I have those in stock, and oddly enough, this integrated circuit and this one in the socket, same one. Now that could just be a coincidence, or it could be that because of the design, they have a tendency to want to fail, or they are the ones that do fail. We're going to pull this one out and we're going to replace it, and then we're going to continue measuring because this one is so far off that it can be affecting other circuits on the board, and we can't have that. So that's going to be the first thing we're going to do. I'll be back in a minute.